So if you compare signals to observables, or especially subjects, they might look like they're almost the same. And to be honest, in certain situations, they kind of are. For example, when we used a subject in a service to share some state between different components, we definitely could have used a signal instead. And that indeed also might be the better way. Here it's just important to keep in mind that Angular has a long history and signals are a relatively new feature. That's why in the past RxJS kind of had to be used for sharing data like this and for managing subscriptions. With signals, you don't necessarily need RxJS for situations like this anymore. It can still be helpful for other kinds of situations, though. Basically, whenever you have some data source that's producing data, like that interval use case I had before. In such a situation, you could absolutely also set up an interval with the built-in setInterval function and fire it every second like this, and then update some signal in here. You could do that, but this here would arguably be less code than doing it like this. Because the equivalent would essentially be to also set up that interval property, which has some initial value, which is another important difference to which I'll get back. Signals have initial values, observables don't, but let's ignore that. We can set up an initial value here. And then in setInterval, we can set the interval signal and update it and get the previous interval number and return that number plus 1, for example. And if we then wanted to map that emitted value to some other value, we would do that by setting up a computed signal here. So the double interval would be the computed function being executed. And that's a function imported from Angular. And we would pass a function to that, and in there output this interval times 2. And we need to read this interval signal. And just as with effect, Angular would recognize that we're using a signal in there, and it would recompute that value and update this double interval property here whenever the interval changes. But of course, as you can tell, this arguably is a bit more complex and more work than using the interval RxJS function and pipe and map. There we had it all in one place and we only needed 1 or 2 lines of code. Here with signals, we're instead managing multiple signals and we have to manage the interval manually like this with setInterval. And I'm not even performing cleanup here or anything like that. In addition, this interval will also always start no matter if we're using that signal value anywhere in the app or not. Whereas with observables, those really only start once you have at least 1 subscriber. So these are some differences which might not matter, but which also might matter. And that's why you have both approaches and why you can use both approaches in different situations. But in the end, the main difference is that observables in the end are values over time. It's a pipeline of values that are emitted over time. Whereas signals in the end are value containers. Yes, you can change the values in those containers and any subscribers then will be notified, but you can also look into the container at any time. You can read the value from a signal at any point in time. You can read it without setting up a subscription. That's optional. It's just done automatically for you if you read a signal in a template or in an effect or a computed function. But anywhere else, you just read a value once. Whereas with observables, you have that stream of data to which you must subscribe in order to get notified about values. And if you do subscribe, you also don't get a value automatically. You'll just get it once it's there. And that makes observables really good for events or anything like that, where values do arrive asynchronously over time. Whereas signals can be really awesome for managing application state. So data which is set to some initial value and which then may change over time, and where those changes should then be reflected in the UI. Ultimately, it of course also comes down to your personal preferences, to the project you're working on, and it's also definitely true that certain problems you might be facing can be solved with either an observable or a subject or a signal. In addition, it's also important to note that Angular gives you some tools for converting from one world to the other. So for converting an observable to a signal and vice versa. And that's what we'll explore next. So you cannot just choose whether you want to use a signal or RxJS in a certain scenario, but you can also convert values between these two worlds. For example, let's say we want to listen to that click count not with help of that effect, but by converting this signal to an observable. You can do this, for example, here in the constructor by calling Angular's toObservable function, which must be imported from @AngularCore/RxJS-interop. And toObservable then does what its name implies. It takes a signal, the click count here for example, and converts that to an observable. And you should not execute this signal function here, but instead pass the unexecuted signal to toObservable. It's also worth noting that you must use toObservable in places where you could also inject values. So either in the constructor or here as a value for a property. So we could also add the click count observable by adding this $sign at the end, which is a common notation for observable properties, that you add a $sign at the end to make it clear that it's an observable that's stored in there. And then you could also call toObservable here to convert click count as an observable and store the result in this property. And with that, we then have this click count observable. And instead of using an effect for listening to changes here, we could go to ng-on-init again and use this click count, the observable, and call subscribe again. And then again, pass this observer object to it, set up the next function that will be triggered for every new value that's emitted. And we would then get that value here. And TypeScript even correctly detects that it'll be a number, because our signal is managing a number starting with 0. And we can then, of course, also console log here and copy this console log statement and use that here, for example. Well, and just as before, we also might want to copy this unsubscribe function here with onDestroy and store this subscription so that we can clean up this subscription if the surrounding component should ever get removed. But with that, we now did convert this signal to an observable, or we created an extra observable based on that signal to be precise. And we can therefore still update that signal. That will still work. But a new value will then be emitted in that observable that was created with help of toObservable. So that's also just another function that in the end produces an observable. And now we're logging based on that observable. So if you save everything and you reload, you'll again see that with every click we got a new log message. But now by converting or by also listening to that signal with help of an observable.